Hello guys, welcome back to my channel, and today we are going to solve one and another very good question. So this question is based on the Bernoulli's equation itself, and we are going to solve it in a very just. Alright, so you can see when I was solving this question, when I was giving the test, I think I am applying something which is very different, or I think it is false. Alright, so we'll start with the question. A wind which is having a speed of 50 meter per second blows parallel to the roof of the house. So you can see there is a case in, we called it chat problem in Hindi. In English it would be like roof problem. So whatever the situation, what the situation is, we have a house, and over the house we have a roof. In certain instances it is made up of steel or iron, and we used to have it when you have a old kind of homes. So there is a pressure which is upward the roof, and there is a pressure which is inside the room. So what actually happened, that the pressure which is inside the room is much greater than the pressure outside the room. Why I'm saying, sorry, yes, why I'm saying that, because on the upward surface of the roof you can see there is a velocity, or the wind is blowing parallel to the in the question also it is given that the wind is blowing parallel to the roof. So what is happening, by due to having a velocity, what exactly the Bernoulli equation is, half rho v square plus rho gh plus p naught is equal to n. So what is happening, when the velocity is blowing upward the roof, the pressure over the head of the roof would be less, because the velocity over here is very greater. When the velocity increases, the pressure automatically decreases to make it constant. Alright, so the pressure P1 would be lesser than the pressure P2. So what happens, that the pressure is always the air always flow from higher pressure to lower pressure. So this particular pressure P2 will exert a upward thrust force that we call up thrust force, that will be equal to del P into area. Area would be the that area of the cross section of the roof, and we have proved that P1 minus P2 is equal to half rho v square. Rho would be the density of the air. Now let's come to the question again. What is given in the question? The area is given to us. Assuming that the pressure inside is equal to atmospheric pressure, that we really don't need the data. The force exerted by the wind on the roof and the direction of the force will be. Exactly, the force, upthrust force, has been asked in the question. So you can make it like a case, and you can store in your memory that there is a case when I learned the Bernoulli's equation, that chat problem. I usually do whatever the question comes, the generalized question, I make it like I have given with a case. So whenever you are given to a particular type or certain type of question, general questions, you have to make it like a case. Like this particular case, we will deal like that. That make your journey very easy. So del P into area. So what is the pressure? What is the pressure difference? So we don't know the pressure difference, so we will go on the force, that is half rho v minus v2 square, v1 square minus v2 square, all right, into area. So outside the velocity, inside the velocity is 0, half rho, the density also given in the question, that is 1.2, and the velocity that is given, that is become 2500, because 50 meter per second is the velocity given, so it becomes 2500, and the area is also given over here, that is 300 meter square. So what you have to do, you have to just multiply, divide it and multiply also. Alright, that would be 6, that would be cut off. Now 250 multiplied by 6 into 300, 0, 6 33, that would be 15 into 300. So you can see 45 into 10 raised to the power 4, and it would be equal to 4.5 10 raised to the power 5. Alright, but the question is, what will be the direction? Of course it would be in upward direction, because the force exerted by the wind on the roof, it would be in upward direction. Alright, because the pressure inside the roof, inside the you can say inside the surface, inside the room is in more than the pressure outside. So because of the blowing, you can say wind, the pressure would be in the upward direction. I think the answer would be D option.